Day 3, the SI base units of measurement. Well, in 1960, there was an international committee, and what they did was establish a set standards for the fundamental quantities of science. And those set standards turned out to be 7 fundamental quantities. And these quantities are called the SI, the System International. All other quantities in science, all other measurements can be derived using these fundamental measurements. And so these fundamental measurements are what we want to call our base units. So let's look at them. We have the measurement of length, which is the meter, mass, kilogram, time, second. Okay, so the first 3 are pretty easy. We can understand those 3. They seem pretty familiar to us. Maybe not the unit all the way, but you know, the kilogram we still might be struggling with, and the meter, but it's just a metric unit of length and mass. So time is in seconds, temperature in units of Kelvin. And you might think, well, no, temperatures in Fahrenheit, temperatures in degrees Celsius. Well, there are conversions between Celsius and Fahrenheit and Kelvin. And so the Kelvin scale is just another temperature scale. So that shouldn't bother us too much either. Now, the amount of a substance, now this is a crazy one. It's called the mole. And you might think, a mole? What are you talking about? Well, we have to have a counting mechanism. In other words, the amount of something. You know, if you have a dozen eggs, you know that you have 12 eggs. If you have a gross of something, usually that means 24. If you have you know, if you go to the store and buy a 12-pack of soda, you know you're going to get 12 soda, you know, 12 cans of soda. So what I'm trying to say is we have to have a counting mechanism in science. And so our counting mechanism for the amount of a substance, our counting mechanism for that is the mole. And you can have 1 mole of anything, and that's going to be equal to 6.02 times 10 to the 23rd. And so that's a 6.02, and you got all those zeros after them. It's a huge number. A mole is a huge number, and you might think, why in the world would we need so many? Well, in particular chemistry, atoms are small, so you need a whole bunch of atoms to have a mole of anything. And so if I had a mole of eggs, then I would have 6.02 times 10 to the 23rd eggs. If I had 1 mole of chicken nuggets, or 1 mole of sticks of gum, anything, you have 6.02 times 10 to the 23rd of that substance. So let's just hit home. You can either have $1 or you could have 1 mole of dollars. Okay, so can you imagine 1 mole of dollars? I can't even count it. I mean, I couldn't even imagine what that would be like. So 1 mole is a huge number. Okay, so 1 mole of anything, there are 6.02 times 10 to the 23rd of that substance. So it's just a counting mechanism. So that one shouldn't be too bad either. You know, the nice thing though for us is these last 2. Well, these last 2 here, we don't really use those in chemistry. But, and so we probably won't even discuss them at all. The electric, except here, of course, the electric current, that has a unit of ampere, and we're familiar with electricity, so that shouldn't be any big deal for us, really. I mean, it has that unit called ampere. And luminous intensity is a candela, and you're familiar with buying different wattage light bulbs. And if you buy a higher wattage, typically what happens is it's a brighter bulb, and so that brighter bulb has more light, more candela. And so that's what the unit is for luminous intensity. So really, when we just think about the SI system for us, we're really going to be focused on these 5. So it's important to know the 7 base units. It's important to know the units and the symbols. So that's a memorization thing that you're going to have to work on in your spare time. So let's look at, remember I said that these base units, all other units are derived from those base units. So we have to give it a new name. So let's just call them derived units. Okay, so like length is the unit of meter. That's a base unit. Time, a base unit, seconds. But speed here is a length per unit time. It is composed of more than one base unit. Meter per second squared is acceleration. There's a length and a time and another time. So there are 3 base units here that compose acceleration. You know, think of area. Length is a meter. Area is a meter squared. So there are 2 base units composed in this derived unit. That's how that works. So all derived units are composed of those 7 base units. So we have speed, acceleration, force, energy, volume, density. These are different derived units that I have just provided. I mean, there are many others. These are just an example. What you should do is look at the different derived units. You should know their measurement of these, and you should know the units and the symbols. So be certain that you know how to look at a derived unit and just use these examples, because I want to make sure that you understand what a derived unit and a base unit are. So you'll need to look at these. Now, sometimes in science we have what are called non-SI units of measurement. Non-SI, in other words, we're not using in other words, we have these units that are not composed of those 7 base units. And so the first example that I provide is concentration. Concentration is given in terms of moles of a substance per liter. All right, moles is a base unit, but liter is not a base unit. Okay, molar mass, grams per mole. Once again, we have the mole here, which is a base unit, but it's not grams that is the base unit, it's kilograms. But we use these units because we find them to be convenient in our calculations. Sometimes force is given in terms of pounds. The SI unit of force is the Newton, but the non-SI would be the pounds. Pressure. We're familiar with pressure being pounds per square inch. The SI unit of pressure would be newtons per meter square. So we're familiar with some of these units because of the English system. The rest of the world, like everybody except the United States, uses the metric system. The United States holds on to the English system. So here's a small sample of non-SI units of measurement. What I'd like for you to do is to know this list, to know that concentration is moles per liter. We're going to use this one a lot in chemistry. Molar mass, grams per mole. We're going to use that one too. Force is in pounds. That's more familiar to us. Pressure, pounds per square inch. We use this one in chemistry. Area, square feet. Volume, cubic feet. These are all things that you need to know their units. Density, grams per cubic centimeter. all of these measurements from this list, I need you to know their unit and their symbol. So study that list.